Hey, we're doing definite integration and we're using the method of U-Substitution. Now I've got the integral going from a to b of e, which is Euler's number, and it's like 2.71 and yada yada yada, raised to the negative 4x dx. Now I didn't plug any actual numbers in here for these limits. We're just going to keep it general. We're going from a and then to b. So the first thing I've been doing here is identifying what u is, and it turns out that we have e raised to some function up here, and that's going to always be what our u is. And so u is defined to be negative 4x. So we take the derivative and we get negative 4 dx. And the next order of business is I was finding the upper limits, right? We're converting our upper limits, and so we would take whatever this is and plug it in for our u, right? Replace that x with our upper limit, and it just turns out to be negative 4b. And then we do the lower limit the same way, taking the a and plugging it in here, and you get negative 4a. Now, our du was equal to negative 4 dx. Well, we didn't have a negative 4 here, but we do have a dx. So we would just put the negative 4 in, but if we do that, we must put its reciprocal outside, which is negative 1/4. And then we're going to go from here and actually do the substitution. So the negative 4x gets replaced with the u, and let's see, well, we just carried our negative 1/4 over, rewrote, oh well, remember we converted our limits, right? Converted those, and then now you need to know that the integral of e to the u is just e to the u. And don't forget the negative 1/4 out here in the front. We draw our little vertical bar here, our upper limit, our lower limit. Then we take our upper limit, plug it in. So we get e to the negative 1/4 b, and then minus, and then we plug in the lower limit, and we get e to the negative 4a. And I just went ahead and left the negative 1/4 outside and didn't bring it in. But so we got this general formula here, which you can do all kinds of stuff with.